So this question says we have a cylinder of mass 1 kg. So this cylinder is, so let me say this is the cylinder that is given to you, and the mass of this cylinder is given to you. So the mass is 1 kg. So I have a 1 kg cylinder, and this is given amount of heat. So Q is given to the cylinder, and Q is 20 and 000 joule. So this is the amount of heat that is given to this cylinder at atmospheric pressure, and atmospheric pressure is this value. So atmospheric pressure is PA 10 to the power 5 Newton per meter square, and this value is given to you. Initially temperature of cylinder is 20 degrees centigrade, that is also given. Now find the final temperature of the cylinder. So we have to find what is the temperature of cylinder. So you see, if you give heat to this cylinder, the temperature will rise, and if you remember, there is a formula Q is equals to ms delta theta. So if you remember this formula, Q is ms delta theta, that is theta 2 minus theta 1. So you can find, if you know the heat m and s, you can calculate theta 2 minus theta 1. So Q is 20 and 000. This is joule. Mass is 1 kg. And a specific heat capacity is also given to you. So a specific heat capacity of cylinder is 400 joule per kg per degree centigrade, that is SI unit. So you have 400. So what is the value of theta 2 minus theta 1? So if you see here, so this and this zeros goes, so this zeros goes, and you divide by 4, so this is 50. So I have theta 2 minus theta 1, this is 50 degrees centigrade. So easy. Now I know the theta 1. What is the theta 1? So initial temperature of the cylinder is 20 degrees centigrade. So what is the final temperature? So theta 2, or I can call this as the final temperature, so TF. So what is the final temperature? That is theta 1 plus 50 degrees centigrade. Are you getting or not? And I know theta 1 is basically 20 degrees centigrade. So this becomes 20 plus 50. So this is 70 degrees centigrade. So final temperature is 70 degrees centigrade. B part of the question says find out the work done by the cylinder. So we have to find what is the work done by the cylinder. You see, why the cylinder will do work, that is obvious. You see, initially cylinder volume is this. Now if you heat, cylinder will basically expand. So you will have something of cylinder. Now the volume of cylinder will increase. So let us say initial volume is V1 and the final volume is V2. So there will be basically a change in volume, that is the V2 minus V1. Now if the volume of cylinder is changing, so what it is doing? It is basically pressing the atmosphere. So it is pressing the atmosphere from all the sides. So it is doing work on the atmosphere. Are you getting or not? So work done by the cylinder is same as PdV. So I have to find work done is simply PdV. Now pressure is constant, 10 to the power 5 Newton per meter square. So SI unit for pressure is 10 to the power 5. And I have to calculate delta V. So this is the only term I have to calculate. We can calculate delta V using heat expansion, so thermal expansion. So if you remember, there is a formula. V is equals to V naught 1 plus 3 alpha delta theta, that is theta 2 minus theta 1. Are you getting? So this is theta 2 minus theta 1, if you remember this formula. Now next line I can write, so this is V minus V naught, this is equals to 3 V naught alpha theta 2 minus theta 1, and V minus V naught is simply V final minus V initial, that is delta V, that is V2 minus V1. So delta V is nothing but 3 V naught alpha and theta 2 minus theta 1. Are you getting or not? Now theta 2 minus theta 1 I have already calculated. This value is 50. So 50 into 3, 150 V naught into alpha. So I have to know V naught and alpha. You see, that is given to you. Alpha is volume. So volume, coefficient of volume expansion is directly given to you. That is 3 alpha is given to you. So 3 alpha, coefficient of volume expansion. Are you getting? So this is not the linear expansion. This is 3 alpha. So 3 alpha is 9 into 10 to the power minus 5. So 3 alpha into, so I have to have 3 alpha value. So let us say I can basically rub this one. So I can write 3 alpha V naught, and theta 2 minus theta 1 is 50, and 3 alpha is given to you. You see here 9 into 10 to the power, so 9 into 10 to the power minus 5. So you will have 9 into 10 to the power minus 5 V naught into 50. What is the value of V naught? For that you have been given mass and density. Mass is 1 kg and density of the cylinder is given to you 9000 per kg per meter cube. So mass by density, that will give you volume. So 1 divided by 9000. So this is 1 divided by 9000. So 9 into 10 to the power minus 5, and this is 1 divided by 9000 and into 50. So what is this value? So this value will come out to be 10 to the power minus 3, 10 to the power minus 5. So this becomes 10 to the power minus 8. Are you getting? So this is 50 into 10 to the power minus 8. So 10 to the power minus 3, 10 to the power minus 5, 10 to the power minus 6. So this is the delta V. What you have to calculate? So you have to calculate work done. Work done you have to calculate. So you have to have PdV. So I know dV. If I plug this value here, so I will have 10 to the power 5 into 50 into 10 to the power minus 8. So 50 into 10 to the power minus 8. So this is 0.05. Are you getting or not? So this is 0.05 joule. So this is the amount of work that cylinder has done to press the atmosphere. Now next part is change in internal energy of cylinder. That is easy. And CVDT we can calculate, or I can also calculate using dq is equals to du plus dv, because I don't know the CV. So dq is equals to du plus dw. So what is the amount of heat that is given to the cylinder? 20,000. You see here. So the cylinder has been given a heat of 20,000 joule. So heat given to the cylinder is 20,000 joule. What is the amount of work that cylinder has done on the surrounding? That is 0.05 joule. You see 0.05 joule. So this is 0.05 joule. So what is the value of du? So this is du, not dw. So this is du. Are you getting? So what is du? So you say du is 20,000 minus 0.05. So this is the value we will have. So what is this value? You can calculate. So this is so 9199. So you will have. So you can calculate this value, or I can use my calculator. So this value is, so let me see, this is 20,000 2000. So this is 20,000 minus 0.05. So minus 0.05. So this value comes out to be 199. So 49 you will have 199. So 49 you have, and 0.5. So let me check again. So this is the value. So 199, 49 you have, and then 0.95. So 0.95. So this is I have 0.95. So this is 0.95. So this is the amount of internal energy that has been changed.